Good evening, everybody, and welcome to this prerequisite level of this college algebra. So we are recording for quality purposes, so don't do anything rash. And we're just going to recap what we did on Monday, very, very late at night. I did the recording through like 1 a.m. in the morning, and I apologize for that, guys. So get my whiteboard out. So today what we're going to be learning is how to FOIL multiply and how to factor like basic polynomials like quadratics and linears, right? Just the basics of factoring. We're not going to factor any trinomials yet because that's a little harder to deal with, especially when you have like a negative leading coefficient or a coefficient greater than 1, right? So I just want to recap really quick. So do you guys remember how to combine like terms? Well, just for recap, like, I don't know, 4D plus 4D minus 3D. Let me think of another variable, like maybe plus 2G minus G plus 6D. Do you guys remember how to do this? Well, first what we did, we found all the like terms, right? Find all the D terms like 4D, 4D, negative 3D, and a positive 6D, right? And then we find all the G terms like positive 2G and a negative G. And you just combine those all together. So let's see. 4 plus 4 is 8. 8 minus 3 is 5, right? So 5 plus 6, you get 11 D's total. And that's just 2 minus 1, which is just plus G. Easy enough, right? And then to recap, we also added polynomials, like if I have like S minus 2T plus 3S, no, 3S plus, I don't know, 5T. So what we did here was just remove parentheses. So we have S minus 2T plus 3S plus 5T, right? And then all you're just doing is combining like terms. So S plus 3S, that's 1 plus 3, which is 4S. Negative 2T plus 5T, that's just going to be 5 minus 2, which is plus 3T, right? Easy enough. And then we also subtracted polynomials. So a recap of that. This is where you had to be very careful with the minus sign next to the other term, because you had to distribute the negative sign. Remember? That gave you a little taste of what we're learning today. So like if I had, I don't know, 5A plus 3B minus the 3A plus 2B, you could remove the parentheses from the first term easy, right? But then this negative sign gets in the way of this, right? So you have to distribute this negative sign in, so you have 5A plus 3B minus 3a minus 2b, right? And then you combine like terms. So 5 minus 3 gives you 2a. 3 minus 2 just gives you a single b. It's that simple, right? But now, what if we took that even further and say we are going to learn about multiplying polynomials? So first I want to go over an example of distributive property. So multiplying polynomials. Okay. So multiplying polynomials. So we're going to go over using the distributive property. So what if I have this? A times A plus B. Okay. So I guess black is okay to use. So what you're going to do, actually, let me do that in a different color so you can understand. So what you're doing is just multiplying in whatever's outside, right? Just like that. So you have A times A. So let me just show you that. A times A plus A times B. Now, when you're multiplying exponents, this is a to the 1 power times a to the 1 power. A times a, that would give you a to the 1 plus 1 power, right? And that's just plus a times b. But a to the 1 plus 1 power, because you're adding exponents when you multiply them, you get a squared plus a b, right? And if you're really confused by this little caret mark here, I'm going to point this out to you guys. This is also a squared in standard exponential notation, right? All right, so here we go, guys. So on your marks. Two times 3c minus 4. Okay, so what you're going to do, again, you're going to use the distributive property, right? And you're just going to multiply that in. So you've got 2 times 3c minus 2 times 4. So that gives you 2 times 3, which is 6c, minus 2 times 4, which is minus 8. See that? That was simple enough. Okay. That's already yellow. Okay, get set. So what if we have, let's say, 3, no, let's make this a little bit more interesting. 3s times s squared minus 3. Okay, so here we go. We use our distributive property again, right? We use our distributive property. Distribute that 3s into these parentheses, right? So 3s times s squared would give you 3s times s squared minus 9 times s. So, and just remember, when you're multiplying exponents, you add them. 3s to the 2 plus 1. So then if you add the exponent, you get a 3s cubed minus 9s, right? See that? That's simple enough. Okay. Go. This one's going to be a little tiny bit more trickier. So what if I have 4 CD minus, let's stick with positives for now. So 4 CD plus 3 C times 4D plus, how about 6C squared times D. And again, I'm gonna point this out to you guys. This is a multiple variable polynomial. If you're still confused by this, but if you're still thrown off by this caret mark, C squared times D, what I mean, that's an awkward C. I need a stylus pen. That is C squared D in just standard handwritten exponential notation, right? So if this is in parentheses, then you can use FOIL multiplication. But if this is not in parentheses, you got to be very careful. This is not 4CD times 4D, not 4CD times 6C squared D. And here's why. You multiply this part in front of the plus sign only, right? So you just copy and paste the 4CD, and then you distribute. What is that? Plus 3C times 4D plus 3C times 6C squared D. Okay, and then you just multiply. So you've got 4CD plus, which is 3 times 4, 12 CD, plus 3 times 6, which is 18. What is that? C to the 1 plus 2 power times D. Ooh, I've got some like terms to combine here. This will give you a taste of what you're going to do in FOIL multiplication. So 4 plus 12 would give me 16 CD plus 18 C cubed D, right? And if you're confused by this notation of the caret, I'm sorry, because only the computer can handle so much you've got C cubed times D, or C cubed D, right? Because a computer can only handle so much. I apologize for that. But I try to come up with some examples of multiple variable polynomials. That way you're just aware. So now it's your turn to practice. Now it is your turn to practice. So um, I'd like to do another variable other than Q is a good variable. Just be aware, I gave you guys a trinomial to try. I will give you one of these to try here as well. That way you're aware. There we go. That's good. I will give you guys a few minutes to give these a try. I haven't had a chance to go to the bathroom while I was lecturing, so I will be right back. Well, guys, hopefully that gave you enough time to actually do these. So I bet this was pretty straightforward here. So let's see. 3 times j minus 4. All you're just doing is just doing distributive properties. So you got 3j, no, 3 times j, and that would be a minus 3 times 4. So the correct answer for the first one is going to be 3j minus 12. Ooh, here's one with a trinomial now. So you've got 4q times q squared, which is 4q to the 2 plus 1, remember? And you've got minus, no, that's, yeah, 4 q times q squared. That is 4q to the 2 plus 1 power, and you've got minus 4q times 4q. That's just 4q inside. That's 4q, the whole quantity squared. In other words, and then you've got a plus 4q times 6, right? So if I had to do a side note on this one, that is at all 4q, the 1 plus 2 minus 4 times 4, which is 16, q to the 1 plus 1, that is plus 4 times 6, which is 24q. So the correct answer for the second one is going to be, correct answer for this one is going to be 4q cubed minus 16q squared plus 24q, right? And this one down here is a little bit harder because I just want you guys to be aware of multiple variable polynomials. So you can't distribute this 5s in the beginning, so you copy and paste that 5s, but you distribute 2t behind the negative sign, so you got a minus 2t. I'm gonna write this in alphabetical order. Okay, this is minus s times 2t. I like to alphabetize my variables and my polynomials, so that is going to be a minus 2t times 4t. Then you've got this scraggly 5s out here. That's going to be minus 2st minus 8t to the 1 plus 1 power. Remember, you got to add your exponents when you're multiplying. So the correct answer for this one is going to be 5s minus 2st minus 8t squared, right? Now with multiple variable polynomials like this, it really does not matter. Okay, time to check some understanding. Time to kind of quiz you on this a little bit now. And I'm not going to tell you the answers here, because this is like an evaluation of what you learned. Good luck on this evaluation, guys. Sorry about that. And a side note, guys, if you're still confused about that caret mark, I should not have to show it again, guys, in exponential notation, because it would save me so much more time. I showed you it a lot in Monday's lecture. I just realized it's now 4 o'clock. So we're just going to get through at least FOIL, multiply, and polynomials, and then we're going to call it for this part. And when I get back home, we will cover factoring polynomials, right? I'll give you guys a couple more minutes on this evaluation. Okay, that should give you guys plenty of time on this evaluation. Now, I would like to go over the FOIL method of multiplying polynomials. FOIL or box method. So whichever you prefer. So now FOIL or box method. I will show you guys the box method as soon as I get home today, just so you guys are aware. But I just want to show you guys the FOIL method, just for right now, if that's going to be okay. So I shouldn't include box method in there. I'm just going to say FOIL method. So, like if I'm foiling the polynomials a plus b times, say, 2a plus b. So the FOIL method works just like this. You still use the distributive property. See? F equals a times 2a. O equals a times b, right? I is equal to 2a times b, and L is equal to e times b, right? And then you're just adding these all, adding or subtracting these all together. And all together, your product will be F plus O. I should say F plus or minus O plus or minus I plus or minus L, right? So what do you got? A times 2a, and remember you add the exponents when you multiply, so you get 2a squared. A times b will give you plus ab. 2a times b will give you plus 2ab. And L will give you b times b, which is b to the 1 plus 1, or b squared, right? And then you got some terms to combine here. So you got 2a squared. 1 plus 2 gives you 3ab plus b squared, right? And does this make sense, guys, when you have this? Okay, I'm sure it does make sense. So on your marks, we're going to start out kind of easy. So like if we have m, no, yeah, 2m minus 3 times m plus 4. Okay, so again, you use FOIL method. So you use FOIL method to multiply this. Just giving you guys inspiration by these arrows. Right? So you use FOIL method right here. So what do you got? 2 2m times m plus 4 times 2m minus 3 times m minus 3 times 4. Okay, so what do you get? 2m times m, which is 2m to the 1 plus 1, or 2m squared, plus 4 times 2m, which gives you 8m, minus 3 times m, which gives you 3m, minus 3 times 4, which gives you 12, right? So you got some like terms to combine here. So you got 2m squared. 8 minus 3 would give you a plus 5m minus 12, right? See that? And I just want to point out to you guys just really quick, be sure to combine your like terms, right? Okay. Shoot. Okay. Get set. This one's going to be a little harder. 2w squared minus 5w plus 3 times, and just to give you guys a hint, that is a product. I'm going to try, how about, let's make this 3w plus 4. And I'm only giving you this time symbol just so you guys are aware. And then you use the FOIL method. Actually, let me do that in this green color. Let me do it in this green color. There we go. So then you use the FOIL method, right? And you got to be sure each one of these gets distributed. Actually, let me go over that in a different color, just so you guys aren't confused by my green there. So there you go. That way you could get a better picture of it. Okay. So what you're going to do is you're going to do the FOIL method. So you've got 2w squared times 3w plus 2w squared times 4 minus 5w times 3w minus 5w times 4 plus 3 times 3w plus 3 times 4. And actually, let me put this in a straight line so you guys can see it. And then once I take the product of each one of these, I get 2 times 3, which is 6. W squared times w is w to the 2 plus 1, which would give me w cubed. 2w squared times 4, that's 2 times 4, which gives me 8, plus 8w squared. And that's a negative 5 times 3, which is a minus 5 times 3 is 15, and that's W times W, which is W to the 1 plus 1, W squared. 5W times 4, and that's a minus again, so 5 times 4 is 20. W, and then I get plus 3 times 3W, which gives me 9W, plus 3 times 4, which gives me 12, right? And I don't mean to like startle you by this, but guys, you've got to combine your like terms, right? So the total product of this with the combined like terms, I get 6W cubed, and that's 8 minus 15, 12, 10, 9, 8, negative 7 W squared, yeah. And then we have negative 20 plus 9, which is a minus 11W plus 12. Those negative numbers really fool me sometimes, man. Really. So just clear all the drawings. Okay. Let's go. Now it's time for us to go. All right, so we have time for just one more example, guys, because the recording is going to have to import to my computer. So we're going to try this. We're just going to make it kind of easy. We're going to do 2c minus d times 5c plus 3d. Okay. So again, you use the FOIL method, right? And then all you're doing is just distributing from 1, 2, 3, and 4. So what you have is 2c times 5c plus 2c times 3d minus 5c times d minus d times 3d, right? So 2c times 5c will give you 2 times 5, which is 10, c times c, which is c to the 1 plus 1 c squared, right? So 2c times 3d will give you a plus. 2 times 3 will give you 6. C times d is just cd minus 5 times 5c times d, which is just minus 5 because you're multiplying by 1, and cd minus d times 3d, which is just 1d times 3d, which is 3d to the 1 plus 1, which is d squared. And then again, guys, beware of this. Please combine your like terms, right? So then you have 10c squared. 6 minus 5 will just give you 1 single cd minus 3d squared, right? And just to be aware, you want your first variable in descending order and your second variable in ascending order when you're thrown off by these multiple variable polynomials. And I'm going to have to stop it right here, guys. I will give you guys a chance to practice these in the next part. just feel free to take a break if you want to. So just make good choices during your break, and I will see you guys later. Bye for now.